Okay, guys, we're taking Cornell notes here, and the topic of our Cornell notes is going to be called free fall calculations. All right, I'm going to talk quick so this video isn't too long. So make sure that if I get ahead of you, you got to pause it so that you can give yourself time to write. Okay, so there's two types of free fall calculations we want to do. All right, so the first type is going to use motion equation. Okay, well, first off, let's do an essential question. Okay, since you guys are doing Cornell notes. So the essential question here is how can I use motion equations? And these are going to be the equations that we learned back in the acceleration unit. Motion equations to find information about falling objects. Okay, so there we go. There it is. You can take a look at the whole thing. Make sure we get that written down. How can I use motion equations to find information about falling objects? Remember, your summary at the end is going to answer that question. All right, let's get right into this. So, first off, we want to do a section on motion equation number 1. Now, this one's going to be fairly straightforward, guys. So, motion equation number 1, remember that motion equation number 1, oops, that's kind of slobby looking. Number 1. Okay, motion equation number 1 looks like this. VF equals VI plus A delta T. And in this equation, VF equals final velocity. VI was initial velocity, which so far, guys, initial velocity. So far, initial velocity has always been 0, but there's going to be times when the ball gets thrown upwards or it gets thrown downwards, and it might have an initial velocity. So we're going to keep that in there. A equals negative 9.8 meters per second squared, and delta T equals time elapsed. And in this case, it's going to be, we can even call it time falling, because we're talking about things that are falling. Okay, so let's talk about this. So I know that I'm going to have VF, and I know that I'm going to have VI, but I can plug in 9.8. So I'm going to end up with negative 9.8 delta T. So what I want you guys to do is box this thing in and highlight it. And this is going to be our new motion equation for free fall. So anytime we have a falling object, we can use that motion equation. Specifically, that equation is really good if we want to find out the final velocity, okay? So let's put that in another box. We're going to say, use this to find velocity. So let's make sure that that also gets boxed in and highlighted, because that is super important. That's the reason we use that equation, is we want to find velocity. Okay, and so let's do it. Let's just do a quick example of using that one. Okay, so if we had a problem that said something like a ball falls for 6 seconds. How fast is it going? So if we had a question like that, I'm sorry about the handwriting, guys, but you're used to this. So ball falls for 6 seconds. How fast is it going? Well, all we're going to do, we're trying to find VF. We're going to assume, so we'll take VF equals VI plus, or excuse me, that's minus. Remember, that's minus. We're looking right here. Okay, minus 9.8 delta T. Okay, so all we have to do is take this 6 seconds and plug it in for delta T. So we'll do VF. Now VI here, we're going to assume that's 0. And we're going to go minus 9.8 times 6. And then all we would do is we just go negative 9.8 times 6. And I'd get negative 58.8. So that would be my answer then. Negative 58.8 meters per second. So you're going to see one like that in your practice. Okay, so that's motion equation number 1. Now, let's do a section on motion equation number 2. Okay, so motion equation number 2. This gets a little bit more complicated. So let me rewrite what that was at the during our acceleration unit. We said delta x equals 1/2 a delta t squared plus vi delta t. Now there's a couple things I want to do here. So first off, we're not using delta x anymore because x is for side-to-side motion. And this isn't side-to-side motion, so let's get rid of that. Sorry if you wrote that down. You should be listening. That's for side-to-side motion, and this is up and down motion. So this has got to be delta y equals 1/2 a delta t squared plus vi delta t. Now, we can also remember that a equals negative 9.8. So I'm going to take that a and I'm going to plug it in here. So I'm going to get delta y equals 1/2 times negative 9.8 delta t squared plus vi delta t. And that lets us do something pretty cool. We're going to make this a lot simpler because, look, I can go ahead and I can multiply these together. So now I'm going to have delta y equals 1/2 times 9.8, which is actually, here I'll even show you guys, okay? So hopefully you guys know that 1/2 is the same as 0.5. So 0.5 times 9.8 actually gives me 4.9. Okay? So now I've got negative 4.9 times delta t squared plus vi delta t. All right, and so that delta y there is how far did it fall? And so what we have now is something that's a lot simpler. And I just want to go ahead and show you guys this too. So remember that delta y is actually yf minus yi. Well, yf, if we're assuming that it hits the ground, yf is probably going to be 0, okay? So really what I've got is I've got negative yi equals negative 4.9 delta t squared plus vi delta t. Now I know that's a lot right now, okay, but there's one last thing I want to do. I'm going to multiply both sides by negative 1. And what that's going to do is I'm going to distribute it, and it's going to change that to a plus, and it's going to change those. So this is going to become a plus, this is going to be minus. So here's our final version of this, okay? So write this nice and neat. Initial height equals 4.9 delta t squared minus vi delta t. So we put a box, and we shade that in. Okay? Now, we're going to use this to find height or time. Because, so that's our height and that's our time. So we're going to be able to find one of those things by using this equation. So let's just do a quick example. Let's do height. So let's say that so this is our example, okay? So let's say that it takes 3 seconds for an apple to hit the ground. How high was it to start with, okay? So this one's going to be nice and easy, guys, because 3 seconds is our delta t. So delta t equals 3. And really, that's the only other thing I need to plug into my equation. So I've got yi equals, we said 4.9 times delta t squared minus vi delta t. So I'm just going to take this delta t and I'm going to plug it in here and I'm going to plug it in here. So I end up with yi equals 4.9 times 3 squared minus, now initial velocity. At the very beginning, the apple's hanging on the tree. It's not going anywhere, so that initial velocity is going to become 0. And then my delta t is 3. Well, what I can notice right now is that 3 times 0 is just 0. So we can cancel that whole ending out. All right. And now I've got pretty easy, okay? So I've got yi equals 4.9 times 3 squared. Well, 3 squared is 9. So let's go do 4.9 times 9. 4.9 times 9. Pretty easy, 44.1. So yi equals 40, what did I say it was? 44.1. Whoop, come on. 44.1 meters. So that's how we can use that equation. All right, sorry that was a long video, guys. Now you guys have the practice sheet to work on.